Two teams of scientists measured the exact same thing, the speed of the expanding universe. Both used the best equipment on Earth. Both checked their math for over a decade, and they got two completely different answers. This isn't a mistake. This is a crisis. Every galaxy in the universe is moving away from us. The number that describes how fast? It's called the Hubble Constant. It tells us the age of the cosmos, the size of everything, and where it's all headed. Get this number wrong, and our entire model of reality is wrong. In 1929, Edwin Hubble first calculated this number. He was wildly off. For 100 years, scientists refined it, argued about it, and slowly closed in on the truth. But as our tools got better, something strange started happening. There are two ways to measure how fast the universe expands. One looks at the ancient afterglow of the Big Bang. The other looks at galaxies near us today. In theory, both methods should agree. In reality, they don't. Scientists studied light from 380,000 years after the Big Bang, called the cosmic microwave background. Using Europe's Planck satellite, they calculated the universe's expansion rate at 67.4. This isn't a guess. It's built on physics so solid, scientists call it exquisite. Now flip to nearby galaxies. Astronomers measured real observable objects, stars and exploding stars, right in front of our telescopes. Their answer? 73, not close to 67.4. A gap that refused to close, no matter how many times they checked. In 2019, Nobel Prize-winning physicist David Gross stood in front of his peers and said something blunt. This isn't a tension. This isn't a problem. This, he said, is a crisis. That word changed everything. Here's the science. Right after the Big Bang, the universe was a hot soup of light and particles. Sound waves rippled through it. When the universe cooled, those ripples froze in place forever, like a fossil. Scientists use this frozen ruler to measure everything. To measure nearby galaxies, astronomers built what they call a cosmic distance ladder. First rung, nearby star positions. Second rung, pulsing stars called Cephids. Third rung, exploding stars called supernovae. Each rung calibrates the next, reaching billions of light years. Cephid stars are cosmic clocks. They pulse like a heartbeat, and the speed of that pulse reveals exactly how bright they really are. Compare that to how bright they look from Earth, and you get their precise distance. This discovery, from 1912, still powers cosmology today. For years, scientists had an escape hatch. Maybe the local measurement was just wrong. In crowded galaxies, starlight blends together. A target star might look brighter than it is, because its neighbor's light bleeds in. That error alone could fake the entire crisis. To settle this, scientists needed sharper eyes. Enter the James Webb Space Telescope. With infrared vision far superior to Hubble, JWST could finally separate individual stars in distant crowded galaxies. This was the test that would end the argument, one way or another. Nobel laureate Adam Rees led a team studying over 1,000 stars across 5 galaxies, some 130 million light-years away. They compared old Hubble data to new James Webb data for the exact same stars. If crowding was the problem, James Webb would prove it. The results were nearly identical. The tiny difference between old and new data was statistically meaningless. There was no hidden error, no blurring problem, no excuse left. The measurement was correct all along, and that terrified cosmologists. Scientists then found something incredible. 2 colliding galaxies, one packed with old crowded stars, the other almost empty of background stars. A perfect natural experiment. If crowding was faking the results, this pair would expose it instantly. The clean, uncrowded galaxy gave scientists the tightest, most precise stellar measurement ever recorded in this field. and it matched the crowded galaxy's results perfectly. There was officially nowhere left for measurement error to hide. Skeptical scientists tried yet another method, different types of stars entirely, called red giants and carbon stars. A rival team claimed these stars supported the OLD, slower expansion rate. But when other astronomers checked their data, they found a hidden 9% error in the rival team's own calibration. So scientists tried something radical: skip the distance ladder completely. Using gravity itself as a lens, a massive galaxy cluster bent the light of a distant exploding star into 3 separate images, each arriving at a different time. They named it supernova H0PE. By timing the delay between its 3 images, scientists calculated the expansion rate using 0 stellar assumptions. The result agreed with the faster rate. A completely different method, the exact same answer. By 2026, astronomers worldwide stopped working in isolation. They built a massive network, linking every measurement method into one unified system. The final number, locked in at just over 1% precision. This wasn't one team's opinion anymore. It was global consensus. So what's actually happening? Physicists now believe something existed in the early universe that we don't yet understand. A theory called early dark energy suggests a mysterious force briefly pushed the universe to expand faster, then vanished, shrinking our cosmic ruler. But here's the twist. Fixing this mystery creates a brand new one. Adding this early dark energy changes how clumpy matter should be in today's universe. And that clashes with completely separate telescope observations. Solve one puzzle. Create another. This isn't just abstract math. The Hubble constant determines the age of the universe, the fate of everything, and whether our best theory of reality is even correct. Right now, one of physics' most trusted models is broken, and nobody predicted it. Scientists spent a decade trying to prove this crisis was a mistake. Instead, they proved it was real. The universe is expanding faster than our equations say it should, and we still don't know why. If this blew your mind, hit subscribe, because Vibeverse brings you the real science behind the headlines every single day.